Okay, hi everyone. So today we're going to continue our discussion about object-oriented programming in Java. We're going to be talking about classes and objects in general, but specifically we're going to be talking about this. Okay, and this is a really important way of making sure that you are very specific about particular things that are going on inside of your classes, inside of your objects. Okay, so anyways, moving sort of back a little bit, it's important that if you want to do some follow-up on this, the Beginning Java 8 Fundamentals book is available from the library at York for York students. That's the link to it right there. All right, so this, what is this? Well, this is this. We'll talk about what I mean by that in a second. So when we're talking about object-oriented programming, we're talking about making classes that can be turned into objects. Well, the classes are plans for how the instantiations become. That is, we have a class and we can use that class as a blueprint for the creation of objects. Okay, we can use them to instantiate multiple objects. We can make one object, we can make many different objects, all from the same class. And each of these objects can have different characteristics and can be used differently, distinctly from one another. So here's an example right here. We've got a class right here called point. And inside of point, you've got a variable called x of type double floating point, and you've got a variable called y of double floating point as well. And then inside of this class, point, which we will make into an object, say p1 or p2, then you've also got basically a method, a function right here called move up. And that it takes units as an input, and it will modify the variable y right here based on the number of units that we want to move. All right, so each time that we call a method, a function, a method of some class, when we're in an object, okay, using the dot notation, then that means that basically we're going to be talking about specific targets for that object. So, you know, when we're talking about, here's the specific object, P1, and so this is of type point, and then we would have a method, say move up, that would be called, and we say put a value 2 in it or something like that, or we could have another method called move down 3 like that, or we could, so that'd be P1 right there, or we could do, say we had another method like this, and it could be a method get position. So so we can have these actions that we can be taken on specific instantiations of a class. All right. So here's examples right here. So we've got P1 and we've got P2, and we set up P1 to be a new object of type point. And again, why are we doing point here and point there? That's because we're talking about the type of object it is, okay? The type of class that we're using on the left-hand side, and then on the right-hand side, that's what's referred to as the constructor, okay? That's the way that we construct it over here. So then we have, that's sort of the setup of P1 and P2, and then we can modify P1 and P2, so the objects P1 and P2, by moving them using these as inputs. All right, so P1 and P2 are objects. They are created from the class called point, right? So P1 and P2 come from that point class, okay? We call them they're called call targets or context objects. So they're targets of that class. They are objects that are derived from or instantiated from that class. So lines 3 and 4 apply the same definition. So line 3 and line 4 for P1 and P2 apply the same definition of the move up method. There's the move up method right there. Okay, and it's applied to objects that come from the class point, and it doesn't matter if they're called P1 or P2, that method is available to them. Now, the question becomes, as you know, we put stuff in memory and we've got these different objects. How does Java distinguish the changes that occur to P1 versus changes that occur to P2? So how do we know that something is happening to object P1 and not happening to object P2, for instance? Well, this is where the this comes into play. So in the method definition, each attribute has an implicit, so we imply, we hide, this, which refers to the context object. That is, it refers to P1 or P2, or if we had a P3 or a P4, all right, in a call to that method. So it is a way of saying it's really associated with this, right? This object, not that object. So here we have the class. We have class point. It's got these input argument, or these input variables, or these variables, sorry, x and y of type double floating point, and we have a constructor right here. This is our constructor right here, and that shows us how things get used, basically, okay, when they get set up as objects. And what we say is that there's two of these input arguments, x and y. Okay, we're calling them new x and new y. And then they get placed down in here. What's going on is we're saying the input arguments, they go into x and y, they're going to be transferred into a variable that's used inside of this class, inside of the objects, called x and y. But we want to make sure that we distinguish between the things that are coming in from the outside, these things right here, and x and y that are used in the context of this particular object, or this, this class, but this particular object that came from the class. And so we say this object, dot x and y. All right, and then in our methods, so that's the constructor, that's our setup. Okay, so this is what happens when we're setting up an object of type of the class, okay? But when we're doing actions on that object, so that's the constructor, we're going to use these methods that are inside of the object, so move up. And when we do that, we want to say we're not interested in new x and new y. That's not what we want. What we want is this x and this y. This refers to the object P1 and P2, whatever object we create, and we want it to be in that context. So we're going to be using this y, and we're going to be taking whatever unit value comes in when we call the method. All right, so each time when the class definition is used to create a new point object, the this reference is substituted by the name of the new object. So basically what we're saying is that in the context of P1, when we call P1 move up, and we say, I don't know, something like that, 2 like that, then what's going to go on here is that this isn't going to be this, it's going to be P1, and it's going to be P1 there, and then this 2 is going to be that. All right, and then if it was P2, then it would be P2 and P2 like that. All right, so let's give some examples here. So after we create the P1 object as an instance of points, so that's the class, that's the object, right? Here's the constructor, that's the object, that's the constructor there, and that is the class. All right, so but we're going to create that object. So when invoking P1 move up, so that's the method that is defined within the class. We're going to be doing it in the context of object P1. So we're going to call move up, but it will be a version of move up that is specific to P1. So basically what will happen is that in the context of P1, okay, this is the P1 object that is of type point or class point, okay? We're going to replace this with P1. Okay, so instead of this dot P1, we're going to do P1 dot X. This is done automatically. You don't actually have to state this. Okay, this is done behind the scenes. And then in the method, that's in the constructor, and then in the method, same thing happens. It'll say we're dealing with this, which is P1, okay, because we have the P1 object, okay, and it's going to be P1 y is going to be assigned the value P1y, the old version of P1y, plus the units. All right, so now let's see what happens with P2. So we've got a P2, this is our constructor right here, that's the object name, that's the class that we're getting P2 from. So when invoking P2 move up right here is the method that we want to use on object P2. There'll be a specific version of move up that's specific to P2 and it'll be used. And so instead of this, it'll say P2 internally. Okay, so that we'll be associating whatever comes in the method, say right here, sorry, that's the constructor. So the 4.7 right there will be brought in there, and then P2 and P2 refer to the this for the object P2. Now, the this reference can also be used, and this is when we use it explicitly. Okay, the thing that was going on before in 3 and 4 were where we're using examples for P1 and P2. Those were really examples of what's happening behind the scenes implicitly. But we can also use them explicitly, okay, when you're writing up your programs. And we use them to disambiguate, to deconfuse. When the names of input parameters, okay, input parameters are the things that we're putting into methods, can we call them? When those names of input parameters clash with the names of class attributes. So for instance, when we have we have a class called point, okay, and here's the constructor. This is typically what we're talking about here. The constructor has an input parameter called x and an input parameter called y. However, inside of our class, we also use the variables x and y. See it right here. Now, when we're talking about x and y, we want to be able to say, to distinguish, okay, when we're talking about those input parameters and when we're talking about the local internal ones. So in a method, what we would do is we would say not x is equal to x and hope for the best. What we would say is the internal version of x is going to be assigned the external version's value, the external version coming in as an input parameter. We do it for another method as well, like set y, etc. Okay, so basically we're saying the input parameter that's coming in from the outside, that's going to be on this side, and we're just going to call it y. But the variable y that's used inside of this class and inside of P1 and P2 and these other objects, we're going to say this.y. All right, so for instance, here is a code fragment that it'll compile, but it's problematic because we're not sure. It's hard to be explicit about and confident about what's going to happen in here. So for the same reason that often in programming we'll put extra parentheses around things just to make sure the compiler doesn't do something that we didn't expect. When we see something like this, where we've got input parameters name and age, but we also have name and age as internal variables, so you can see them right there. What I want to do is say this.name and this.age and this.age to say that we're using the internal versions, not the ones that come in from the outside. Okay, so always remember to use the this when input parameter names clash or are the same as the class attributes or the internal class variables. Okay, so here's the example right here. So these are the internal variables. And so we want to make sure that we use this in that case. And then here are the things that come in from the outside. And we don't put this in front of them. Okay, so we're making sure that the internal components have this attached to them using the dot notation like that. All right, so this and that. Good luck, everyone.